Hi guys, welcome to this video on exponential and circle graphs. It's another two graphs that I'm attempting to help you understand. So, keywords here are exponential and radius. Exponential is when something grows really quickly. That's exponential growth. And then the radius is the distance from the center of the circle to the circle's circumference. Now in the method I've got the general forms of the equations. So the general form for the equation of an exponential graph is y equals k to the power of x. The k is a positive number and the x coordinate is the power. That's what we use as the power. Pop the x coordinate in, you're going to find out the value of y. And it's good to remember that anything to the power of 0 is equal to 1. Very useful indices rules in this particular topic. Now the general form for the equation of a circle is x squared plus y squared equals r squared. Now the x squared plus y squared bit, the fact that it is written like that, that means that the center of the circle is at the origin. And at GCSE level we don't have to worry about anything that's harder than that. Circles will not have a center that is not 0, 0. And the r stands for the radius. So if we have the number at the end of this equation, we can square root it to find out what the radius is. And that might be a whole number that we get as an answer, or it might be a surd. If it's a surd, we have to estimate where the radius is. Okay, now let's look at this first question. This is not too tricky now that I've explained what that equation means. All right, so we know because of x squared plus y squared, we know the center is at 0, 0. Okay, we also know that the radius, because that is 25, if we square root it, we'll get the radius. That equals 5 or minus 5. Okay, and all you're going to do is plot the points on the x and the y axis at 5 and minus 5. And then you're going to join them up and draw a lovely smooth circle. Now that is easier said than done sometimes. What I would recommend that you do is get a compass, plot the point of the compass, put the point of the compass on 0, 0, and then set it to 5, and then just draw your circle round with your compass, right? What I'm going to do is draw a circle on there just to show you what it would look like using the tool that I've got. So if I draw that on there, that's almost good enough. That one's just gone over the 5 there a little bit, but that'll do me. All right, I'm happy with what that looks like, enough for me to not have to do it again. All right, so there you go. There's that. It's unfortunately going to disappear, but I will do question 2 now for you. Question 2, draw the graph of y equals 2 to the power of x. That means that the x coordinate value is the power, and this therefore must be an exponential graph, a graph that's going to get bigger really quickly, steeper really quickly to look at. So we're going to put the value of 0 in there first, and that's going to be 2 to the power of 0. And anything to the power of 0, as I mentioned before, useful to remember, it's just 1. All right, so that then is going to give us the coordinates of 0, 1. So we'll plot that there, 0, 1. Then 2 to the power of 1 is going to be 2, so we're going to get 1, 2 to plot. That goes there. 2 goes in as our value of x. 2 squared is 4, and that is going to give us 2 and 4 to plot as a coordinate. And the last one that we're actually going to be able to plot is 2 to the power of 3, and 2 to the power of 3 is 2 cubed, which is 8. That's going to give us 3, 8 to plot. So we plot that point up there. 2 to the power of 4 would be 16, so that would be 416. 2 to the power of 5 is 32, 64, 128, 256. You might learn the powers of 2, but you don't need to necessarily. You could always work it out on a calculator if you needed to. And then we just join those up with a nice smooth curve, and that's not too bad actually. It's one of the best curves I've drawn so far, I think. Yeah, and that's what would happen there. Now if we went into the negatives on it, -1, power of -1, right, you'd be thinking about getting closer and closer towards the x-axis, but again it would never reach that x-axis, right? So state the point of intersection with the y-axis is what I was going to say but didn't. I just paused for a little bit, but now I said it. So we're going to put in the the point of intersection just as a coordinate, 0, 1, simple as that. The graph is going to go through that point, right? And it does. That's it there. Done. Right, moving over, let's have a look at question number 3. Now the graph of x squared plus y squared equals 16 has been drawn on the grid. There it is in the purple. right? That's, you can see it's going through all the 4s and minus 4s on the x and the y axis because the square root of 16 is 4. It's already been drawn. Draw the graph of y equals 2x plus 1 and estimate the solutions to the equation 5x squared plus 4x minus 15 equals 0. Well, what's the connection between this equation and these two equations? Well, what we would do is we pop in this expression here. This is solving simultaneous quadratic equations. We'd take that as a term. We'd pop it into where the y is, because that is what y equals. And then we'd write it all out, collect it all together, take the 16 off that side. We'd end up with this as a quadratic, right? So this is solving a simultaneous quadratic equation graphically. And I thought I'd chuck this question in here because it's to do with circles, all right? It's to do with the equation of a circle, isn't it? So what I need to do is to be able to draw a straight line, and I will attempt to do that. And I will zoom in a little bit if I can. No, I won't do that yet. I'll plot the points first, then I'll zoom in. So first of all, I'm going to try plot in. Let's go from -3 to something. Let's start at -3. Put that into here and draw this straight line on there. So 2 times by -3 is -6, and -6 plus 1 is -5. So I'm going to go to -3 minus 5 and just plot that point. Then I'm going to go to -2, put that in. That's -4. -4 plus 1 is -3, and that is there. Hang on, have I done that right? No, that's not mine. That's not 5. That's 3.5. I plotted that point wrong. Didn't look right. Right, start that again. So there's -3, -5 down there. There it is. -2, -3 is there. -1 goes in. That's -2, -2 plus 1, -1. So you can see we're going across by 1 and up by 2. Yeah? Oh, I've plotted it wrong again. Doesn't look right at all, does it? There it is. That's right down the bottom. So cross by 1, up by 2, 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 cross by 1, up by 2. Alright, now we've got that line drawn. Alright, let's zoom in to that and see if we can draw a lovely straight line. And in fact, maybe I don't need to just zoom in just yet. Draw the line first, then we'll zoom in. Alright, because we need the points of intersection between the circle and the straight line that I've just drawn. So I'm going to go from that point there and find out one of the x values. So the x value there I think is probably about 1.3. We'll say that's 1.3, and then we'll go across there and we will, no, doesn't like that, does it? Don't know why it's not doing that. Need it to, really. Let's zoom out, try and zoom in again. Oh, it's having a funny 5 minutes, isn't it? Love that. Brilliant. Great times. Wonderful time to make that happen. There we go. That one liked it. That one's working. Is that going to work now? That doesn't want to draw a line there, does it? Don't know why. Anyway, the point what I'm trying to make is we've got an x value here and we've got an x value here. We've got a y value here and a y value here. All right. So I'm going to say that when x is 1.3, y is 3.8. All right. Let's say that. And then if x is -2.2, then y is, that's a little bit lower than that. Let's say -3.3. All right. So let's go with those as our values. I'm going to zoom out of that and I'm going to try and write those things in. That's going to disappear, unfortunately. So if x is equal to, and it was about 1.3, wasn't it? Then y was about, and we can kind of just guess it from there anyway, 3.8. Alright, and if x is equal to minus, say it's about there, wasn't it? -2.2, then y is equal to, and that was -3.3. Alright, so there's our solutions to that particular quadratic equation. And if you substituted your value of x in there and that value of x in there, you should get something near 0. Alright, and you could check that on a calculator if you wanted to. I hope it is, because I mean I've used the graph and I've done the best I can do. Alright, so it should be something that's near 0. Alright, feel free to check that one. If it's not right, drop me a comment, let me know, and I'll do the video again. Alright, thank you so much for watching this one. I hope you've enjoyed it as much as you can enjoy a video about exponential and circle graphs. Yeah, take care of yourselves, look after one another, do your practice. Practice using the link in the description, making new resources for you. Yeah, take care. See you in another one.